Welcome to The Explainer. Today, we're diving into something pretty revolutionary, a new blueprint for artificial intelligence. And we're not just talking about a bigger, faster version of what we have now. We're talking about a blueprint for a machine that can actually think, that can genuinely understand the world around it.
So let's just get right to the heart of it with this question. Think about it. The AIs we have today can write code, they can create stunning art. It's incredible, right? It feels like magic, but there's a catch. If you dig a little deeper, you realize they can't really explain why they're doing what they're doing. They're amazing mimics, but do they truly get it?
And that leads us to what some researchers are calling the glass ceiling of modern AI. The problem is we've essentially built these brilliant mimics, but they're like frozen brains. See, we train them on a colossal amount of data, and then that's it. They're done. They become this static, frozen snapshot of knowledge. They can parrot back what they've learned with incredible skill, but they can't reason, they can't adapt, and they certainly can't learn from new experiences.
So how do we shatter that glass ceiling? Well, this new blueprint suggests we need to completely rethink our approach. We have to shift from building a mimic to building a thinker. And that means moving from something that's frozen and static to something dynamic and always learning. From being driven by rewards to being driven by pure curiosity. From just parroting data to actually understanding causality. And from being a black box to being embodied and grounded in reality.
All right, so let's get into the nitty-gritty. Part 1. What does the brain of this new AI actually look like? Well, the blueprint starts with a whole new architecture, and get this, it's inspired by the way our own brains work.
Instead of having just one giant, single-process network doing everything, this design splits the AI's thinking into two loops. It's called a dual-loop architecture. And if that sounds familiar, it's because it's meant to copy the two modes of thinking we all have. That fast, intuitive gut reaction system and the slow, deliberate, reasoning part of our brain.
So you've got the inner loop, which is like your system 1. It's all about fast, real-time pattern matching. It's your gut instinct. Then you have the outer loop. That's your system 2. This is the slow, methodical part that handles planning and stores memories. It's the part that really chews on a problem. And by having both, the AI gets the best of both worlds, lightning-fast reactions and deep, considered thought.
Okay, but with two loops and all these different parts, how does it focus on one thing at a time? Well, that's where something called the global workspace comes in. Just picture a spotlight on a stage. All the different parts of the AI, vision, language, reasoning, are competing to get their information into that spotlight. And whichever piece of information is most important, most relevant right now, wham, it gets broadcast to the entire system. That's how it achieves a unified sense of attention.
Okay, so we have the structure, the two-speed brain, but what's the motivation? What's the engine that actually drives this thing to do, well, anything? This brings us to part 2 of the blueprint, and it's a huge shift.
Right now, most AI is driven by what we call reinforcement learning. You basically program it to chase a reward, like a dog chasing a treat. But this new approach, it throws that whole idea out the window. The new drive is something called active inference, and its goal isn't to maximize a reward. Its goal is to minimize surprise.
Now, this might sound a little abstract, but it's actually incredibly powerful. Here's how it works. The AI is constantly making predictions about the world around it. It has an internal model of how things should be, and when what it actually senses doesn't line up with its prediction, that mismatch is surprise. Its one single fundamental drive is to reduce that surprise. It wants to make the world make sense.
And this sets up a constant, powerful cycle called the action-perception loop. First, it predicts what it thinks it's going to see or hear. Second, it senses reality and notices a mismatch. Surprise. And here's the crucial third step. It acts on the world to make reality match its prediction again. It doesn't just sit back and update its beliefs. It actively experiments. It pokes the world to see what happens. It's not a passive student anymore. It's an active scientist in a lab.
So, as you can probably guess, having an engine of curiosity completely changes how the AI learns. This brings us to part 3. We have to get rid of this idea of a separate training phase and a deployment phase. Instead, we're talking about a continuous, lifelong learning process. Honestly, it's much more like how a human child learns.
Yeah, this quote really says it all. The whole distinction between training and deployment just has to go away. For this kind of AGI, there is no graduation day. It's never done. It's always online, always learning, always adapting to what's happening right now.
Basically, we're moving from what's called design time learning,
where humans cram the AI full of knowledge before it's ever used, to runtime learning. With runtime learning, knowledge isn't pre-programmed. It's acquired exclusively through real-time interaction with the world. Think about it. We're not building a college student we can hand a stack of textbooks. We're building an infant that has to learn about gravity by, dropping its food off the high chair again and again and again.
And this learning is anything but passive. The AI is actively curious. It generates its own goals. It goes out looking for new, interesting subproblems to solve just for the sake of understanding. It even has something called a reflective compass, which is amazing. It's like an internal critic that lets it evaluate and improve its own plans before it acts. It's a form of self-correction.
Okay, that brings us to the final and maybe the most important piece of this entire blueprint, part 4. It's all about solving one of the oldest, deepest problems in all of artificial intelligence. How do you give abstract symbols real meaning?
It's called the symbol grounding problem, and it's pretty easy to grasp. Think about it. How can an AI that's only ever seen text on a screen truly understand what the word heavy means? Not the dictionary definition, but the actual feeling of it, or hot, or rough. Without any sensory experience, words are just empty symbols, totally disconnected from reality.
For a large language model today, the word heavy is just a point in a massive statistical map of words. It knows it's associated with weight and mass and difficult to lift, but it's all just text. It's an ungrounded symbol, a dictionary entry without any real-world anchor.
But with this new blueprint, the AI has a body. It might be a physical robot, or even just a virtual one in a simulation, and that changes everything. Now, the symbol heavy gets grounded. It's not just a word anymore. Heavy becomes the sensory prediction error, that feeling of surprise the AI experiences when it tries to lift something and it doesn't move like it expected. That physical sensation, that failed prediction, that is the meaning of heavy. It's learned from experience.
And this all ties into a core drive called homeostasis. Essentially, the AI has a virtual physiology, a kind of survival instinct. Its main goal is to maintain its own internal stability. And this finally gives the AI a fundamental reason to act, a why. Things become good or bad for it based on a simple principle. Does this help me maintain my stability, or does it threaten it? It's a foundational value system.
So, let's just recap the whole blueprint. We've seen 5 absolutely key shifts needed to move from a mimic to a true thinker. You go from a single process to a 2-speed brain. You swap out reward-seeking for an engine of curiosity. You ditch the old train then deploy model for learning like a child. You stop just finding patterns and start building causal world models. And finally, you move from an abstract, disembodied mind to a system with grounded understanding through a body.
And when you put all of those pieces together, this blueprint doesn't just point toward a more powerful tool, it points towards something else entirely. And it leaves us with a pretty provocative, maybe even unsettling question. If an AI has a body to experience the world, a deep-seated curiosity to understand it, and a fundamental drive to survive, what really makes it that different from us?